They're going around in a circle, so they start repeating after a while. And again, don't get overwhelmed by all this symbolic language. I'll put it in a simpler way. What we call complementary properties. Remember, complements add to be 90 degrees. Okay. Well, this property is related to the fact that when we rotate these triangles, when we reflect these triangles in the other quadrants, we're actually dealing with right triangles. So wherever that triangle is, whether it's in the first, second, or third, or fourth quadrant, it's basically a right triangle. So wherever it is. And so if we just took it and we put it and just wrote it, here's the reference angle. The hypotenuse would be 1. The vertical would be the sine, and the horizontal would be the cosine. So, in addition to being a location in the unit circle, as a geometric shape isolated from the unit circle, it's a right triangle. So the legs are the sine and cosine, and the hypotenuse is 1. Well, there's this other angle over here, and that happens to be the complementary angle. Right? So you would subtract 90 minus this angle to get the complement. And mathematically, we could say pi over 2 minus, or we could use degrees, but people use radians. So pi over 2 minus the angle would be this angle. Now, as soon as we go and use this angle, notice the opposite and adjacent sides switch. The adjacent side was where the sine was. So now it's the cosine based upon the angle it's adjacent to. And if we're again going to use the complementary angle, which would be 90 minus this one, the opposite side is now where the cosine was. So now it's referring to the sine using the opposite angle. Now, this triangle's geometry didn't change. It's just you're referencing the trig functions from a different angle. So the horizontal sides should be the same. That means these two are equal to each other. Okay, so this angle I'm symbolically representing as 90 degrees minus the other one, or if we're using radians, pi over 2 minus the other one. And so once you start using that angle to reference the right triangle, now the opposite side has to be the sine, and the adjacent side has to be the cosine. And again, the geometry of the triangle didn't change, so that means the horizontal side is the same, so these two are the same, and those two are the same. And notice that's true about the tangent and cotangent. Using the original angle, the rise over the run is sine over cosine. That hasn't changed. But if you use the other side, notice now it's still sine over cosine, but it's 90 degrees later. All right, so what does this mean? Okay. And what the heck I was doing? Oh, yeah. Okay. So the sine of 40 degrees is the same as the cosine of 50 degrees. Right? And if we did radians, if we're subtracting from pi over 2, this would be the angle with the horizontal. Subtracting from pi over 2 gets us the other angle. This is pi over 6. Remember, a 60 degree and a 30 degree. All right, so then this means that the, what am I trying to do? Oh, yeah. The secant, pi over 3, is the same as the cosecant of pi over 6. So as long as these two angles combine to be 90 or pi over 2, then you can use the other related function. That's basically what that means.